Today, we are going to master Grafana Loki's query language LogQL. I'm going to show you how to go from just staring at a wall of text to becoming a master interrogator, someone who can solve basically any production incident that comes your way.
Okay, picture this. It's 2 in the morning. Everything's quiet, the world's asleep.
And then you hear it. That buzz, that vibration that just jolts you right out of bed. Yup, an alert has fired.
And here's the problem. The payment service is failing. But only sometimes. It's the absolute worst kind of bug. It's elusive, it's intermittent, and it is happening right now.
This is really our whole starting point. We have this mountain of logs, right? But they're just noise, completely useless until we can ask the right questions. And that's exactly what LogQL is for. It's the tool we're going to use to find that one critical signal hidden in all that noise.
All right, let's dive in. Our first step is probably the most important. We need to ignore every single log that isn't from our broken payment service. We're about to take this massive sea of logs and shrink it down to just a single manageable stream.
So this right here, this is the foundation of every single LogQL query you will ever write. It's a log stream selector. Inside those curly braces, it works on your indexed metadata. Things like the app name, the environment, the cluster. And because it filters on this index before it even tries to read a single log line, it is incredibly fast. This is the single most important thing you can do for query performance.
Now, take a look at these operators. They look pretty simple, right? But don't let that fool you. They give us unbelievably precise control. We can ask for an exact match, we can exclude something specific, or we can use powerful regular expressions to match, say, a whole pattern of pod names. This is how we target exactly what we need, and nothing else.
Okay, let's put this into practice. We're here in Grafana's Explorer view, and by the way, you can try all this yourself at play.grafana.org. So we'll start with our stream selector. Service equals payment service, environment equals production. And just like that, boom, we've just filtered millions of logs from our entire system down to only the service we care about and the one environment that actually matters right now.
So, now that we have the right haystack, it's time to find that needle. We know there are errors somewhere in our services logs, so let's go hunt them down.
I mean, this slide just perfectly illustrates the power of line filters. Look on the left. We have everything. Info, debug, error logs, it's just a wall of text. But by adding one simple line filter, we get the view on the right. Only the log lines that contain the string 500. All that chaos is just gone.
Now, the crucial takeaway here is all about performance. The pipe equals ILAST operator, which just does a simple contain search, is by fastest. You should always use it first to drastically cut down the number of lines you're searching. Then, if you need more precision, you can chain on a slower but way more powerful regex filter like pipe/I.
Okay, back to our demo. We take the query we already have, and we just add a pipe followed by IDE RLEAT equals 50-500. As soon as we run it, you can see the log view updates in real time. Every single log line that doesn't have that exact string just disappears. And now, what we're left with is a clean list of our 500 errors.
We've found the error lines, which is awesome. But the most important details, I'm talking about the request ID or a specific error message, they're still locked inside that raw text. We need to break it open and turn it into structured data we can actually query. This whole schema on read idea is an absolute game changer. Unlike older systems where you had to define this rigid structure before you even collected your logs, Loki lets you figure it out at query time. We just ingest raw text, and then we use parsers to apply a structure on the fly. This means our analysis can evolve as we learn more about the problem. It's so much more flexible.
Let's see it in action. We just add JSON to our query. And instantly, Grafana recognizes the structure and shows us all these new fields we can work with, like request ID, user ID, and error message. So now we can add another pipeline stage to refine our search even more, like filtering for only those errors that actually have a request ID.
Okay, so finding individual errors is a huge step, but it's not enough. To understand the real impact, to know if this is just a minor glitch or a full-blown major outage, we need to stop looking at individual log lines and start measuring them. It's time to turn our logs into metrics.
This is the question every single on-call engineer has to answer, right? Is this a slow trickle of problems or a raging fire? The answer to that question determines the urgency of our response, and just looking at a list of log lines can't tell us that. We need a number. We need a rate.
This is the moment we pivot. We're about to write what's called a metric query. We're going to use the same building blocks we already have, the stream selector and the line filter. But now we're going to wrap them in a function that doesn't return text. Instead, it's going to return a number that's been calculated over time.
And the perfect tool for this job is the rate function. It takes our filtered log stream, looks at it over a time window that we define, and it calculates the per-second rate of entries. It's the perfect way to answer, how often is this thing actually happening?
And here it is, the final transformation. We wrap our entire log query inside that rate function, and we specify a time window, in this case 30M for 30 minutes. We switch from the log view to the graph view in Grafana, and bam, we no longer have a list of logs. We have a time series graph showing the exact rate of 500 errors over the last half hour. Now we know exactly how bad it is.
Okay, let's just step back for a second and look at the journey we just took. We started with this vague, middle-of-the-night alert, and we ended with a precise, quantifiable understanding of the entire problem.
And here it is. Each part of this query was a deliberate step in our investigation. We targeted the right service, we filtered for the error signal, we parsed the line to extract context, we refined our search with that context, and finally, we quantified the impact. We built this query one single piece at a time.
You know, this is the most important takeaway of all. The real skill isn't memorizing a bunch of complex queries. The real skill is in the process, starting simple and then, step by step, adding selectors, filters, parsers, and functions to zero in on the answer.
Look, every piece of information you need to solve an outage is probably already sitting there in your logs. The key is knowing how to use LogQL to ask the right questions and finally unlock those answers. Thanks for joining me.